Hello friends, welcome to engineering tutorial. So here we'll discuss some important AC terminologies, some important terms associated with alternating current. In the previous video, we discussed the basic concepts related to alternating voltage and current. Here we'll discuss some basic terms. So a quick review. So alternating voltage and current, they are parameters, signal waveforms which change in terms of both magnitude and direction. Their magnitude and direction both changes with respect to time. The polarity of the voltage or current, it changes at regular intervals of time, fixed intervals of time, and that results, the alternating voltage applied to a circuit results in an alternating current. Okay, so when alternating voltage is applied to a circuit, that results in an alternating current. So this is the AC voltage waveform. Here we have used sinusoidal waveform for simpler mathematical analysis, where it is expressed as this, and it results in the AC current waveform with the given mathematical representation. So now the important terms associated with alternating current or AC. So first is waveform, the shape of the signal waveform. So waveform is basically the shape of the curve which is obtained by plotting the instantaneous values of voltage or current, Vt or It, with respect to time, where voltage or current is plotted on the y-axis and time is plotted on the x-axis, ordinate and abscissa. It is called as waveform or wave shape. So as you know, here the AC voltage and AC current waveforms, they are sinusoidal in nature. Okay, sinusoidal in nature, sinusoidal shape. So why? It leads to simple mathematical analysis. Okay, so as we have seen in the first video, now it is not necessary that the AC waveforms should be sinusoidal in nature. They can be other shape as well, like they can be square, like this. They can be triangular, they can be any shape. Okay, they can be any shape, the signal waveforms. So here we'll express xt, t, xt, t. They can be in this way, okay, so any shape it can be. The only thing is that a specific fixed pattern should be repeated. A fixed pattern should be repeated after a fixed interval of time. That is the only requirement. But the reason why we choose sinusoidal voltage and current waveforms, it is because it becomes easier for this simple mathematical analysis. It can be expressed in the form of a simple mathematical equation. This, the voltage waveform Vmax sin omega t, Vmax sin omega t plus phi, where there is an initial phase angle, and the current waveforms similarly Imax sin omega t, Imax sin omega t plus phi. So here if we plot the different instantaneous values here, okay, here if we plot the different instantaneous values at different time instants, let's say like this, at t1 this is, at t2 this is the value of the voltage, at t3 this is the value of the voltage. So by plotting the instantaneous values at different time instants, we get this kind of a shape, okay, the sinusoidal shape. So that is called as the waveform, the shape of the waveform. There can be other shapes as well, as we have seen, triangular, square, sawtooth, different waveform shapes. Okay, so this is the waveforms. So as I said, the waveform is always taken as sinusoidal for simpler mathematical analysis. Then we have the instantaneous value. So this Vt here in this equation which we discussed, Vt or It here, this Vt, okay, or here the It, this is called as the instantaneous value. This is the instantaneous value of voltage, this is the instantaneous value of current. So value of the voltage at specific time instant t, it is expressed as Vmax sine omega t. This is the value of the current at specific time instant t, Imax sine omega t. So here suppose we want to know at a specific time instant, let's see this, what is the value of the voltage. So we'll plot it like this. This is the value of the voltage. Let's say at this time instant, this is, let's say t1, this is t2. At this much time instant, what is the value of the voltage? So this will be the value of the voltage. Similarly, at this much time instant, what is the value of the voltage? So we will plot it. This is called as, these are called as the instantaneous values of voltage and current. At specific time instant, what is the value of the voltage or what is the value of the current, which is expressed as per the mathematical relationship. That's why sinusoidal waveforms are very helpful. Okay, so because of this simpler mathematical analysis it allows us to do. So this is called as the instantaneous values, Vt or It. Okay. Then we have the cycle. So here I said that in alternating parameters always a fixed pattern is there. Okay, a fixed pattern is repeated. So here the fixed pattern is the parameter, the value, it starts from 0, then goes to the positive maximum value, then again drops down to 0, again goes to the negative peak value, maximum value, again goes to 0. This positive half cycle followed by a negative half cycle, this constitutes one complete cycle. Okay, this constitutes one complete cycle. Okay, a positive half cycle followed by a negative half cycle. So a particular pattern is completed. 0, positive maximum value, again 0, negative maximum value, again 0. This completes one cycle. This is called as one complete cycle of the waveform. So here if we consider the square waveform, here this is, it is starting from here. Okay, it is starting from here, let's say like this, here, then here, then here, then here, then here, then here, again goes back to 0. This is the positive half cycle, this is the negative half cycle, and this completes one cycle. Okay, one complete cycle, and again from here another cycle is repeated. Okay, same, again another cycle. This is the first cycle, this is the second cycle. Again here starting from 0, this is the positive half cycle, this is the negative half cycle. The more positive maximum value, again the negative maximum value, again 0. This constitutes one complete cycle. Here also this positive, negative, starting from here, positive max, then 0, negative max, and then here. Okay, this here. Okay, this completes one cycle. So this pattern, the time taken to complete the pattern of the waveform, that is called as the cycle. One complete pattern, it is called as the cycle. And then we have alternation. So this half portion of the complete cycle, it is called as the half cycle or alternation. So this complete cycle, it consists of a positive half cycle and a negative half cycle. So this half cycle is called as alternation. Here also, this is the positive alternation, this is the negative alternation. Again followed by a positive alternation and a negative alternation. Again positive alternation, negative alternation. So these are the half cycles, the positive half cycles and the negative half cycles. Two half cycles, positive and negative, complete one cycle. Okay, two alternations, they complete one full cycle. Okay, so we have discussed waveforms, instantaneous values, cycle, alternation. Then we have time period. So the AC waveform, it completes a positive half cycle, then a negative half cycle. This completes one cycle. So the time taken to complete one cycle, it is called as the time period of the signal waveform. The time taken to complete one full cycle. So here this is expressed in terms of omega t. So if we express it only in terms of t, this will be the time. So this is with respect to phase, but just ignore this omega and let's say we draw it with respect to time only. Then the time taken for this one cycle, that is called as the time period of the signal waveform. It is the time taken by the signal waveform to complete one full cycle. Okay, starting from 0, positive half cycle, again back to 0, negative half cycle, that completes one full cycle. So the time taken for that one full cycle, it is called as time period. It is represented by t. Then we have frequency. So frequency is, let's say, in 1 second, how many full cycles of the waveform can be completed? In 1 second, how many complete cycles of the waveform can be completed? Okay, that is called as frequency. So frequency is number of full cycles, complete cycles of the waveform completed per second. That is called as frequency. Okay, so let's say a signal waveform, it completes 2 cycles per second. So its frequency will be 2 cycles per second, or it is also called as 2 hertz. 1 cycle per second is called as hertz. So 2 hertz. Let's say a signal completes 3 cycles per second. So then it will be 3 hertz. The frequency will be 3 hertz. Okay. So here there is an important relationship between time period and frequency. Okay. Both are inverse, they're inversely related. Time period is the reciprocal of frequency. Frequency is the reciprocal of time period. Okay, t is equal to 1 by f, f is equal to 1 by t. Okay, inverse relationship. Okay, this t is equal to 1 by f, f is equal to 1 by t. So suppose we have frequency given, we can easily calculate the time period. If we have time period given, we can easily calculate the frequency. Just do the inverse, 1 by f. Okay, this is the relationship between time period and frequency. Let's say we have frequency is equal to, let's say 10, okay, 10 hertz. We have frequency 10 hertz or 10 cycles per second. Then the time period will be 1 by f, which is equal to 1 by 10 equal to 0.1 seconds. It means the time taken to complete one cycle is 0.1 seconds. Similarly, if we have time period given, let's say t is equal to 0.1 seconds, we can easily calculate the frequency 1 by 0.1, which is equal to 10 hertz. It means 10 cycles per second. 10 cycles per second. Okay, so this is the relationship between time period and frequency. An important thing here, an extra information, that the frequency of the power system, the power supply which is supplied to our homes, it is 50 hertz. That is, the signal waveform, it completes 50 cycles in 1 second. Now it is used, most commonly used, because it provides the best results for operating any kind of electrical machinery. Okay, so time period, frequency, then we have is the amplitude. So here if you see this plus Vmax minus Vmax or plus Imax minus Imax here in for the current, okay, this is for voltage, this is for current, this plus Imax minus Imax, the positive and negative maximum values, the positive and negative maximum values, they are called as the amplitude of the signal waveform. Okay, the positive and negative maximum values, they are called as the amplitude of the signal waveform. Here, this and this, they are called as the amplitude. So whenever it is asked what is the amplitude of the signal, just the positive maximum value or negative maximum value, we do the modulus of it, that is the amplitude, the positive and negative peak of the signal waveform, that is called as the amplitude value, the maximum value attained by the signal. Since alternating voltage, it changes its direction, it goes both positive and negative, so the positive peak is equal to the negative peak in terms of magnitude. It is opposite in direction, opposite in sign, but the magnitude of the positive peak is the same as the magnitude of the negative peak. So it is the maximum value, positive or negative, which is attained by an alternating signal, alternating waveform. It is also called as peak value. Okay, so these are the important things. Again, here the relationship between angular frequency omega and frequency, that is equal to omega is equal to 2 pi f. Okay, so here f, here the angular frequency, it is expressed in radians per second, and frequency, it is expressed in hertz. Okay, this is expressed in radians per second, this is in hertz, cycle per second or hertz. Also omega is equal to 2 pi by t, because frequency is equal to 1 by t. That's why if we substitute f with 1 by t, it becomes 2 pi by t, omega, the angular frequency. So we can express the different, the alternating quantities like this. Vt is equal to Vmax sin omega t, then Vmax sin omega with 2 pi ft, we can write it also in this way. Also Vmax is equal to sin 2 pi by capital T multiplied with this. So these are the different ways of expressing an alternating quantity. Okay, so these are some of the important terms associated with alternating signals. Okay, so here we have discussed them.